Yeah, so I'll discuss about if you may know that this month in January there was the CES 2026.
Yes.
So I want to discuss some topics from that. So there are a lot of announcements. So today I'll just focus. I won't just exactly focus on the announcement from CES, but I got some ideas about what topics to discuss. So I'll start with the hardware and robotics thing. So do you know which is, as of now, which is the most adapted form of autonomous robots that people use today?
No. But like you're talking about humanoid robots.
Not exactly humanoid, but in that similar vein. So what is the most accepted form of robotics that are intelligent that people use?
The ones that are used in car manufacturing, those kind of robots.
Yeah, that is one good guess, but from the consumer point of view, that is an industrial robot.
Okay.
From the consumer point of view, the most used form of robotics today is actually vacuum cleaners. So,
Yes.
robot vacuums are the most common forms of autonomous robots. So, these are intelligent and they run on their own without much input. So, as of now, they have 63% of the market share of the US market is of consumer robotics is taken up by these vacuum robots. And because of this, it has taken a sort of, it has made people accept robotics or autonomous robots in people's house. People may not think about of this that deeply, or I don't know if they do, but it is a robot that has access to your personal space, and it can map the entirety of your house. It knows, like, since it has to clean the floors, it knows the layout of your house. So people are allowing such autonomous robots. Since it does not look like a human walking around, talking to you, expressing his thought, people have accepted it. But in a sense, it is doing the same thing, but for a very small case right now. But this is what some can call as the starting point of the robotic evolution or revolution. So it has started with a utility driven approach where people are okay with an intelligent robot that is being used for cleaning. And even this robot did not start with being this intelligent. It had a very simple mechanism before. So it had a bump and turn kind of system. So it will go one way, when it bumps into something, it will change directions and so on. But now even that has a lot of advanced technologies like SLAM. SLAM, I think it stands for stands for simultaneous localizations and mapping. So it knows by itself the layout of your house, and it can route the area how it wants to clean it. It also has LiDAR sensors and so on. So, and talking about robotics, this vacuum robots could be considered as the first kind of device or robotic instrument that people have accepted into their home, which is truly autonomous. And this acceptance of vacuum robots then also gave rise to similar kinds of other robotics that is in the rise. We, in similar veins to vacuums, we have robot pool cleaners. So, and we have also robotic lawnmowers. So they by themselves will just mow the lawn. And similar use cases will be seen in social and in companion robotics. So I don't exactly know what kind of robots are there, but I see some clips here and there sometimes. And not only robotics, there are some apps that you can attach. Like I have seen some videos of an Apple app, and they will sell like the body. So the intelligence is in the app, and the body is just it is a separate hardware. You can attach the phone to the body, and then it can emote like it is like an animal or something. I, so basically, these are the most popular use cases of autonomous robotics today. And also, slowly, like from the past few years, we are seeing a lot of news of humanoid robots also from different Chinese companies, from Tesla. I think this 1X Neo is the first one that is available for the consumer to buy, if I'm not wrong. And yes, it is expensive by at $20,000. Like as it mentions here, we can get a mid-range car for that price. But slowly but surely, it is becoming a reality where you can choose to buy an humanoid robot if you want. And may one of the big reasons the industry was able to go this way was because of this adoption of vacuum robots. But the current use cases of the robots, of the vacuum robots, of the lawnmowers, etc., are limited. If we want to move towards a truly autonomous humanoid robot future, there is a big gap to cross. Current AI is the digital AI, and the actually what I found funny was when I was reading the source, they mentioned it as traditional AI. So this came out like 2 3 years ago, and we already were calling that to be the traditional AI. So that is a digital AI only. It is great at language tasks and images and videos as well, but it is limited to the monitor, to the display. It lacks understanding of the physics. It has no grasp of the gravity, does not understand space, etc. So we have to move to physical AI, and that requires an upgrade to the brain of the robot. So it must possess physical common sense. It should be able to understand and reason about its space. It should understand the concept of permanence of an object and the consequences of the laws of physics. And that is where the NVIDIA's infrastructures comes into play. So NVIDIA has a full stack infrastructure for everything. Now, if we start talking about it technically, it is too complex for me to understand also. So I tried to simplify it as simple as possible and used a very simple analogy to understand the process. So basically has three stages in its pipeline of training physical AI. The first stage you get related to being in the classroom. So it contains of computing and training. So a robot has to process lots of data, even petabytes of data, to understand its world movement. So it requires supercomputers to process all that data. NVIDIA is providing it through its DGX and the Rubin platform. So this will act as a teacher to first teach the lessons to the robot. Now, second stage would be to practice it. Just learning or seeing it is not enough. You have to, just like if a person is watching someone picking up the dumbbells, that is not enough for him to build a muscle. He has to go and do it himself. So this is where the robot will simulate and practice the uh, movements. But it is uh, a risk if we actually let the robot practice out in the real world amongst people. It could cause unnecessary harm, etc. So the best possible scenario is for it to learn in a simulation, and that simulation occurs in first it used to be Omniverse and Isaac Sim from NVIDIA, and in the recent, I think in the CES itself, they announced a new world foundation model called the NVIDIA Cosmos, which is able to predict the physical consequences. And then once we have the chip that is capable, it has learned, it has practiced it, we can then deploy it into the body of the robot. Now, in this three stage, one thing that NVIDIA is at least not part of now is the actual development of the hardware or the physics of the hardware, like the mechanical nature. If the robot is even capable of moving like an actual human being, that is, I don't think this pipeline is involved in that. So assuming that the robot is physically capable of those movements, How can it be intelligent? That is where only I think the NVIDIA's infrastructure comes into play. Then, yeah, some of these are the announcements from NVIDIA in CES. The NVIDIA Cosmos, this is the World Foundation model, this is the software. The Rubin platform is the hardware with a lot of processing power. I'm sure the numbers are quite high, but I don't really know about that. And yeah, some partnerships also. Basically, this is the pipeline from NVIDIA at least that will be used to bridge the gap between current reality of the hardware to the physical AI. I'm sure there might be other players as well giving this kind of infrastructure, but almost always NVIDIA seems to be the one that is talked about the most. So that is why I just used NVIDIA. Next, so talking about the movement from robot, I think I'm not sure if this term is used actually formally somewhere, but I may have read it. But the term robot zero point 0.5 is where we are at. So these are most of the time wheeled platforms that have somewhat humanoid upper bodies, and the hands are not exactly human-like. They are not dexterous. They may have simple spatula-like movement, and the environment in which they work is specific environments like factories, logistic warehouses. So where the environment is semi-structured, and there are standard tasks, and their capabilities are also limited. So they can do repetitive physical work that are standard. So pick and place them somewhere, move the boxes around. So they are not fully general purpose. But and so, like I mentioned before, the way to bridge this gap is to upgrade the brain of the AI. So this involves vision language models. So the AI should be able to understand its visual, uh, what it is seeing visually. It should be able to understand the language, what people are asking of it. From those inputs, it should be able to predict the outcome as realistically as possible, following the laws of physics. That is where the world models will come into place. And to train it all, you need a simulation. That is where we have Isaac, Cosmos, etc. So if we envision the future of a humanoid robot, it will be a fully humanoid. It'll have two legs, five fingers, and not limited mobility with full dexterous hands. So it can almost mimic, or ideally fully mimic, a human's motion. Only then it can use tools that are actually designed for humans. And the environment in which it will have to be able to work is diverse. It cannot just focus on working on a standardized area. It should be able to work in areas that are chaotic without much logic or rules, so where anything pops up out of anywhere. So yeah, so it has to have intricate manipulation and yeah, those things. Then that is the higher level picture of where a human like robotics mostly is today, and what the future could look like, and what are the steps to help us reach from humanoid robots from the current forms of robot. But there are also surely some hurdles along the way. So mainly there are three. The first one would be the cost. The one that you can buy to the humanoid robot itself costs 20K dollars. That is not really, you cannot tell that is affordable for most people to own in their homes. Even if it can do like someone's laundry at 50% of the efficiency, it's better I do it myself than spending $20,000 to get a machine that can do it half as well as me. So today you cannot justify the cost of this kind of machines for everyone. Also, there is a huge economic disparity in different countries. So price sensitive markets like India, you will not see, like in America, like I said, 63% or so consumer market is vacuum robots. I don't know how much that is in India. I have never seen. Probably in very uh, high net worth individuals might have few in their homes, but most people, even upper middle class, are not buying vacuum robots because it does not justify the cost yet. So the upfront cost of this kind of robotics is still huge. One potential solution for that is RAS, or robotics as a service. You could, instead of buying the hardware as a whole, like in full cost, you are renting it essentially. Like you rent a maid, you may get the vacuum for a few hours to clean your house. Or you could, yeah, there are different ways you can interpret this, but you can subscribe to the hardware as a service. Then there are, of course, negatives and positives to this, but initially, to make it affordable, maybe that is one of the ways. Then, secondly, of course, data privacy and security. We are talking about a very intelligent mobile sensor system. It has sensors all over the place. If it wants to be truly humanoid, then if it is living with you, it knows everything about you. It is seeing you, it can understand you, what you talk about, it can even move around your house. So, how much are you willing to trust the robot, the company, even if the company guarantees they do not have any ill intentions? How can you ensure that it is completely hack proof, that the cybersecurity features are all properly implemented? So there's a huge question of security that has to be addressed if you want it to be accessible, or if you want it to become a mass market thing. And the third problem would be of these safety and regulatory regards. So a humanoid robot, by the time a humanoid robot comes, we can assume that I don't know how much likely it is we will get AGI, but whatever AI we have at that point, it will be very smart, or smart enough, and then it will also be strong enough because it is mechanical hardware. Then the topic of safety comes, because today all those industrial robots are in confined spaces. Even then, people going into those spaces have to be extra careful and responsible as to know, so that no accident occurs. You will have such humanoid robots walking amongst people in the chaos of the traffic or the other places. So how should a human and robot interact, and what laws should govern their safety and such? These are things, if we really want a humanoid future to exist, I'm sure, but like there has to be some laws or regulations regarding this. That's about it. Do you have any points regarding any of them?
Okay. Yes, I do have some things to talk about. But I was thinking maybe you could end this video because this is your presentation and we can do the Q&A in the other video. Then it'll be easier to do.
But we can just continue in this one, right?
Uh, okay, I'll continue because I was thinking like the presentation session versus a discussion session should be different. But anyways, okay, if you're
You can make
yes,
it just one thing, right?
okay. Uh, so first thing about the hardware and the software are two different aspects of robotics that it is. And the hardware is mostly a mechanical and then
Yeah,
electronics
electronics,
and electrical.
electromechanical.
Yeah, that's that kind of problem. So that requires engineering from that perspective. And from that perspective, the humanity robot has already made a lot of progress, as you can see from all the demos by Boston Dynamics. So that's already there.
Yeah.
But when you talk about the brain, that was the thing that was keeping humanoid robotics from becoming like human. And that is the only thing that's still keeping. So that's
Yep.
the hard part because even in real life, the brain is the most important thing. Like for example, in a company, the difference between the CEO and an entry level of a person is not the physical thing. If anything, the entry level person is younger and probably more stronger than the CEO.
Hmm.
But is the CEO that has decades of experience, the intelligence that's what makes him or her at the top. So that's the thing. Uh, but in terms of the physical aspect, I have learned that hands are the most difficult thing to engineer for a robot. Because I've actually seen a video about this, and like the research and R&D is going on there, and that's one of the most difficult thing to engineer,
Hmm.
the hand part of robotics. And then about 1X robotics that you mentioned, I actually made a video, I think last October or November. It was a solo video where I talked about this thing. 1X Robotics, and there was another company as well, Sunday Robotics as well. So there is another company that's also working on humanoid robots. So there I mentioned this thing that to train a robot, see, ultimately those are machine learning algorithms, and machine learning algorithms, the main thing is data. The more data there is, the better it is. So the reason why it's very good in text, audio, video is because there are
Hmm.
lots and lots of data. That's why they're good. And the limitation that's being told about physical robotic is that there is no data. People haven't collected those kind of specific human movement data yet. And so that was the thing. So in the video, I talked about that while researching for the video, I found that there are multiple ways in which they're trying to solve this data problem. So the first option is this teleoperation. Like there's a robot which is being teleoperated by a human, and it is that's the training data. Like suppose I am teleoperating a robot. I'm walking. What was that movie where the Hugh Jackman
Real
robots?
still.
Yeah, yes, something like that. That is teleoperation. So I train everything. So all those movements are captured. So that's practically me. That's the training. That's the training data. That
Hmm.
is directly me teleoperating those things. That's one way. And I said that that's the objective of 1X robotics right now. So $20,000 plus very limited capabilities. It's not for mass market adoption. So in technology, there's always the early adopters, like those who are tech savvy people. They will always buy those things, like try out the new technologies. So most probably they are going to buy those things. And initially, 1X Robotics has a lot of, it has very limited capabilities, and they have also said that that thing can be taken over, like that thing can be teleoperated if needed. So there is also a security concern that was mentioned because you have this robot in human in your house that could be operated by someone else.
Yeah.
So that was one. So the main objective was that people they want to like put it in people's house and collect data, training data for those things. That was the primary objective here. So because initially it will have very limited capabilities. But as I said, there are three main approaches that are found for collecting data. The first one is this. The second one was the approach that was used by Sunday Robotics. What they did was they created this custom gloves kind of things.
Hmm.
So here you don't have to directly teleoperate the actual robot. They do have their own robot. That's a separate product, but for training they have a separate whole project going on where they have these custom gloves that people can wear and do their everyday tasks. And that is how they're collecting data. So now that is much easier because it is much easier than teleoperating a robot. Easier and less expensive too. So that's another way, essentially. And the third one that you approach that you talked about is those virtual simulations, like
Mm.
training a robot in a simulated world, and then using those data to train the robot. So those are the three things that
Yeah.
I remember. And yeah, so far that's what I've thought about. And
And
also,
also,
yes, yeah, you can continue. Then I'll say all my things.
yeah, what I was thinking was that talking about, like, as you said, solving the issue of realistic human movements of fingers in robots is the difficult part. Like, what robot it is, I'm not sure it is. I think it is by Unitary, maybe. Like, that is popping up in a lot of different. So it can do flips and stuff. It can do martial arts, and some singers are also using them as dancers in stages. That I've seen some videos like that, and they're doing some pretty complex dance movements. So like 90% of, so I think reaching to the point where it is 90% similar to a human being is similar, is easier, or I think almost solved. Going from that 90% to reach 100% is where the entire challenge will be there, because that is where the finer details will be needed. So like, for example, a human being can do most of the thing in the world without having finer hand movements, and the robot can mimic that. But there are some minute things that humans can only do with the finite, not with the fine use of the fingers, and maybe that will take a lot of engineering advancements in order to become reality.
Yes. I don't know what the term was called, like this long tail of something was it was called. I forgot the term actually. The thing that you're talking about, like to reach from 0 to 90, to reach from 90 to 99% is it requires the same amount of effort that it requires to reach from 0 to 90. And again from 99 from 99% to 99.9%, it requires the same amount of effort that's needed from 90 to 99. It is something called long tail of the something. I forgot the term.
Hmm.
So that was the thing we're talking about.
This kind of,
And
like, actually concept applies to almost everything, I think so. Like, in terms of maybe learning some skills also, in order to
yes.
learn 50 to 60% of the skill, you will pick it up quite quickly. 60,
Yes.
70 to 80% requires more effort, and very few people can reach the 100% of anything. So the similar logic applies here.
Mm. The next thing was about world models. Like recently, Jan LeCun, who was a researcher at Meta, yeah,
Hmm.
he also left and he's starting his own company. I forgot what's the name, but it's a world model company. And there is another researcher named Fei Fei Li. She is also she also has her own startup. She's actually a professor. I think I'm not sure it's Caltech or Stanford, probably Stanford, if I'm not wrong. So she also has her own startup on this world models.
Hmm.
And like from Ian LeCun and Fei Fei's perspective, like that's the next stage of evolution for AI. They said that LLM has its limitations. Like it can never completely understand the world because they are only learning patterns in text. They do not have the idea of how the physical world works.
Hmm.
So they're wor- that's what they're working on. And I think Gemini is also working on those things
Yeah.
because yeah, they have also one of some model. I forgot the name, but I think last September or August it was they released their third version of that. I don't exactly remember the name right now, but they're also working on those. And like logically, it makes sense because LLM definitely it's called the next word or next token predictor. Like it takes those things, but in
Hmm.
a textual way. They do not know how to grasp the physical world. So Yeah, I think I'll have to look more into the technical details of how world models work and so on to comment more of it. But it makes sense that they have to learn those things.
Hmm.
And final thing, yes, I also remember now. The hardware part, that was it. Yeah, that's one thing. Because right now we are using all those AI models, the chatbots, but none of them are working on our devices.
Yeah.
All the data, everything, all the processing is being done at these cloud, means at their own servers, the inference. So if you want to create a robot, so either you have to do two things, like the robot has to be connected to the internet, in which case, if they're at a place where there's no signal, so they are just statues, they become statues.
Hmm.
So they can't reach true autonomy like a human being. Like we are not attached to a cloud, like we can go anywhere.
Yeah.
Actually, that reminded me of a Black Mirror episode where a person was actually her brain was connected to the internet. She can only exist within one area. If she goes out, she becomes unconscious. So, anyways, so right now, I think those devices are called edge devices, edge computing.
Yeah.
So I'm not sure how powerful those edge devices are currently because they have to be really powerful because they have to be even more powerful than LLMs, those world models, because they have to make real-time decisions and act if they want to like completely act like humans. That's another thing that people like all like a lot of articles and videos that I read they talk about the next things data is the or compute is those kind of like is the next frontier or like the next bottleneck or something. But they don't talk about the size of those things because you want to put it into like in a portable device because a human robot has to be a portable device. It cannot carry a whole data center along with it. So how can within its own body it can make those kind of decisions? So I think
Yeah.
that's the most difficult thing because right now the whole news is about how data centers are so big they consume the water of entire states. That's the whole news about those things. So if they're so big and they require so much power, so how can we expect a humanoid robot, which I think in principle should require even more power than that, to fit that huge data center into one single human-sized body? Yeah,
Hmm.
I think so. That is going to be the most difficult because, yeah, of course, data is definitely difficult to collect. But even suppose data is collected, so it will require a lot of hardware engineering will be required, like innovation in hardware engineering will be required to shrink that data center into this capacity, like a small thing.
Or if
But
satellite internet becomes widespread, that could also make sure connectivity to the server is always there.
yes, yes, that could be one solution. Yeah. So I think that is why the thing is that Elon Musk's companies are so vertically integrated. Like it has its own ecosystem because Elon Musk owns Starlink. He has this Optimus robots, so he doesn't have to depend on third parties. Plus, he also has his Grok, Twitter, the textual data. So that is why, like the analysts that I listen to on YouTube and articles that I read, they said that in the long run, these are the kind of advantages that Elon Musk's company has. This vertical and horizontal, all kind of integration is there.
Hmm.
So I think Optimus can benefit from Starlink's connection because Starlink can have the satellite internet all over the place. Yeah.
Yeah, and also lot talking about limitations of hardware. So next time I plan to talk about wearables and AI wearables. So that like the idea of the limitation of the hardware will come there. So we can discuss more then.
Okay. So
So
anything else?
no, can I think we can end it.
Okay.